Good morning to all of one. Today we are going to discuss the first topic of the physiology, that is homeostasis. So homeostasis discusses the concept of constancy, that is maintenance of constant internal environment of the body. So we need to remember two important and prominent personalities here. The first one is Claude Bernard. Claude Bernard describes the changes in external environment that leads to body trying to maintain the internal environment. And he used the word milieu interior. So this word we need to remember. It was used by Claude Bernard. Describe the changes in the external environment that leads to the body trying to maintain the internal environment. And he used the word milieu interior. The second personality we are going to remember is Walter Cannon. Walter Cannon. He coined the term as we know it, homeostasis. So these two facts we need to remember for now. Claude Bernard used the term or word milieu interior, and Walter Cannon coined the term homeostasis. So now we are going to learn control systems of the body. The control systems body are 3 in number. The first system is negative feedback control. The second system is positive feedback control, and the third one, which most of you wouldn't be familiar with, is feed forward control. So there are 3 control systems in the body: negative feedback control, positive feedback control, and feed forward control. Negative feedback, positive feedback, and feed forward control. So let's discuss them one by one. We're going to take an example of exercise. When we're doing exercise, there is increase in blood pressure. This increase in blood pressure is leading to body bringing the blood pressure back to normal, that is decreasing the blood pressure. Here we see during exercise our blood pressure increases, but our body works on different systems and decreases the blood pressure. This is an effective example of negative feedback control system. So we are discussing this exercise phenomenon. In this exercise phenomenon, blood pressure control is a form of nervous control, that is through action potentials. You need to understand this part. This blood pressure control in our body is a form of nervous control. Nervous control, different nervous systems, different components of nervous systems are involved, different parts of the brain are involved, different nucleus of the brain are involved, and that is through the action potentials. Action potentials will be fired, the nerves will be activated, and different sympathetic and parasympathetic systems will be activated or inactivated, and that will lead to the control of our blood pressure during exercise. Another example is the opening of sodium channels. So when sodium channels open, this leads to sodium influx. Sodium influx leads to depolarization of the cell membrane. So the depolarization phase of action potential. This depolarization phase of action potential leads to more and more opening of sodium channels. This we need to remember, that the depolarization phase of the cell leads to more and more opening of the sodium channels. This leads to further depolarization of the cell. This concept is also known as amplification. This amplification of sodium channels called Hodgkin's cycle. So in this Hodgkin cycle, we have seen that when the sodium channels open during the depolarization phase, sodium influx happens and depolarization of action potential takes place. This depolarization leads to more and more opening of sodium channels. This and leads to further more and more sodium influx. This leads to further depolarization of this cell. This concept is also called as amplification. That is, the function gets more and more amplified, and this cycle is called Hodgkin cycle. So Hodgkin cycle is also involved in amplification. Another example, during this exercise, we have also seen that we do not do exercise, but we simply merely think of doing the exercise. That is, thinking of doing exercise. Most important fact is there is no stimulus. In this part, we are only thinking of doing exercise, but there is no stimulus for the exercise. This leads to rise in heart rate and respiratory rate on anticipation. We are merely anticipating the work of exercise. We are not doing any exercise. There is no stimulus for doing exercise. There is increase in heart rate and respiratory rate on anticipation. This is called anticipatory control system, or as we have seen beforehand, feed forward control systems. So we have seen three scenarios during exercise. During exercise, there is increase in blood pressure. Body tries to bringing the blood pressure back to normal, that is decreasing the blood pressure. This is an apt example of positive feedback control system. Then also during exercise we have seen the Hodgkin's cycle, that is how more and more sodium channels open following more and more increasing negativity of the cell inside, that is inside of the cell, also known as the depolarization phase of the action potential. This is the amplification. Amplification takes place during positive feedback control system. Only during this positive feedback control system this amplification takes place. This cycle is also known as the Hodgkin's cycle. An example of the anticipatory control system or feed forward control system is that when there is no stimulus. For example, during this exercise phenomenon we are doing no exercise, so there is no stimulus, but we are merely thinking of doing exercise, like we are going for a jog or doing a running or playing football or any doing exercise. There is increase in heart rate and respiratory rate on anticipation. So this is called the anticipatory control system or feed forward control system. So we have taken the example of exercise and we have seen three types of system. Now we are going to discuss one by one the three types of system. The first we are going to discuss is negative feedback control system. So we are going to discuss there is a phase of stimulus here. There is going to need be a stimulus in this control system. Stimulus, for example, we take increase of blood pressure. This increase in blood pressure is the stimulus that leads to activation of receptors. In this blood pressure, the receptors are the baroreceptors. These baroreceptors are activated on increase in blood pressure. These baroreceptors send signals to center through the cranial nerves. Cranial nerves 9th and 10th. Glossopharyngeal nerve and the vagus nerve. The center in this case of regulating blood pressure is the medulla. And from this medulla there are medulla effectors. Medulla effectors, the sympathetic system and parasympathetic system. So of these two systems, one needs to be activated and one needs to be inhibited. So this leads to activation of parasympathetic system. This activation of parasympathetic system leads to decrease in blood pressure. This is the final effect. So you have seen from the starting that there is a stimulus. Stimulus, for example, being increase in blood pressure. The stimulus is carried by receptors. In this case of regulation of blood pressure, receptors are baroreceptors. The baroreceptors gets activated. We are going to learn detailed mechanism in the control of the vessel in the CVS system. So for now we are going to only learn the mechanism of this. These receptors carry information through the cranial nerves through the 9th and 10th nerve to the center medulla. In the center medulla, the medullary effectors act through either sympathetic system or parasympathetic system. So the effect is going to be activation of parasympathetic system. Activation of parasympathetic system leads to decrease in blood pressure. So you have seen that the stimulus is increase in blood pressure leading to decrease in the blood pressure. This is called barrow reflex in controlling the blood pressure. So this is one example we have seen. Another example is that we have the endocrine hormone regulation. For example, we have seen the levels of T3 and T4 hormones, that is the thyroid hormones, are regulated by TSH from anterior pituitary. An exception to this mechanism is estrogen and LH hormone surge during menstrual cycle. We are going to see this phenomenon in positive feedback regulation. For now, remember this exception that estrogen and LH hormone surge during menstrual cycle is an example of positive feedback regulation, but majority of this endocrine hormone regulation falls under the negative feedback control regulation system. Next, we are going to discuss the concept of gain. So this concept of gain is the degree of effectiveness. The degree of effectiveness is assessed by gain. Formula for this gain is correction in the values divided by the remaining error. This is the formula we need to remember. So we are going to see an example, a simple example during the regulation of blood pressure. During exercise, our systolic blood pressure increases to 180 millimeters of mercury. Before exercise, it was stable at 120 millimeters of mercury, and at the end of exercise falls back to 150 millimeters of mercury. So we are going to calculate the gain during this entire process. So gain is correction by error. So the correction happens that from 180 it falls back to 150 millimeters of mercury, but originally we had 120 millimeters of mercury, so the error remained 150 by 1 minus 120 millimeters of mercury. So this comes 30 by 30, which is 1. We are going to apply a negative sign here. So this gain is going to be minus 1. So why we are using this negative sign? Why the negative sign? This is because the starting and ending phases are in opposite directions. And what is meant by this? See here. We had before exercise the normal at 120 millimeters of mercury, the systolic blood pressure. During exercise, it rises to 180 millimeters of mercury. That is, from here it increases. But at the end of exercise, it falls back to 150 millimeters of mercury. That is, instead of increasing further, it decreases. So the starting point and the ending point are in opposite directions. From 120 it increased to 180. Then when coming back to normal, instead of increasing further, it falls. So that's why we call the starting and ending phases are in opposite directions, and this leads to this negative sign of gain. This we need to remember. Don't put any sign on the starting, just calculate the gain and then see in which directions the starting and ending phases are going. If they are in opposite directions, put the negative sign. If they are in the same direction, then it should be a positive value. The gain would be positive. So you've seen that this gain is correction by error. We have seen this already. This formula is an important formula. So we're going to see what happens when this error value is 0. This error value is in the denominator. This becomes 0. Then this leads to gain becoming infinite. This is such an absurd concept. When the error value is 0, the gain becomes infinite. This happens called infinite feedback gain. This is a concept of infinite feedback gain. This happens by kidneys of our body during regulation of blood pressure. So I'm just saying here, we are going to learn more about this in the cardiovascular system. And there are two types of regulation of blood pressure. There's a short-term regulation and there's a long-term regulation. This kidneys to long-term regulation of blood pressure. By doing this, they bring back the systolic blood pressure to 120 millimeters of mercury. As you have seen before in this exercise example, that the original systolic blood pressure is 120 millimeters of mercury. So at the end of this long-term regulation of blood pressure, the error is equal to 120 minus 120. 120 was the original and it came back to 120. So the error becomes 0. Leads to gain is infinite. This concept you should understand and remember that kidneys are involved in the infinite feedback gain. So this completes our negative feedback regulation. Next we are going to discuss the positive feedback regulation. After negative feedback regulation, we are going to see this positive feedback regulation. Simple most understanding we are going to get, that is, there is an initiating stimulus that leads to amplification of stimulus further. This word we have seen this before. This amplification is going to happen only in the positive feedback regulation. There is an initiating stimulus. For example, increase in blood pressure, increase in the hormone levels, increase in the iron concentration, opening of more and more sodium or potassium channels. There could be an initiating stimulus that leads to the amplification of the stimulus further. After the initiating stimulus, the stimulus gets amplified, increased multifold times further. This is called positive feedback regulation. So we're going to see some examples here. First example we're going to see is the clotting mechanism. Classic mechanism, for example, a clotting mechanism. This involves the cascade pathway. Amplification of the factors called clotting factors. There are numerous clotting factors that are involved in the formation of a clot. After we damage a tissue or a vessel or surface of the skin, we are going to discuss this in the hematology section. For now, remember that this is a cascade. This word is important. The cascade pathway amplification clotting factors leading to formation of a stable clot. The stable clot is important for stopping of the bleeding. The next example we are going to see is the LH surge. I've told in the negative feedback explanation that all the endocrine hormone regulation are negative feedback regulations, except there is an exception, it is the LH surge. During the menstruation, there is increase in estrogen hormone. During ovulation, that is just before this ovulation, this estrogen hormone level increases. This leads to increase in the LH levels, and as we know, this increase in LH levels causes the LH surge. This LH surge leads to ovulation. So as we have seen, this increase in estrogen hormone leads to increase in LH levels. So this amplifies, increase in estrogen hormone amplifies the LH hormone levels, which leads to LH surge and finally ovulation. A third example we are going to see is the classical example of action potential. As we have seen in the previous example, the Hodgkin's cycle. So as you have seen, sodium channels opens, leading to the depolarization. This leads to further opening of sodium channels, leads to further depolarization. So this sodium channel opening further opens the sodium channels and leads to further depolarization, that is, it amplifies the further actions. So this action potential is another example of positive feedback regulation. Another fourth example we are going to discuss is the example of parturition. During parturition, that is the delivery of fetus, the fetal head that comes out first, the fetal head that presses the uterine cervix. This fetal head that comes out first during the parturition process, it presses the uterine cervix. This leads to activation of nervous signals. This activation of nervous signals leads to this important phenomenon, release of oxytocin. As you know, this oxytocin is a powerful contractor of the muscles. It contracts the muscles of the uterine muscles and uterine cervix muscles, and this powerful contraction pushes the baby down further. This is important. This release of oxytocin pushes the baby down further, and as we have seen from here, leads to fetal head descent. As we've seen here, this fetal head which tries to come out first, it presses the uterine cervix. This leads to activation of some nervous signals that leads to release of oxytocin. From where we know this is from posterior pituitary. This oxytocin pushes the baby down further and the fetal head descent. Fetal head descends. So this leads to the amplification. I am repeating this word again and again, so we are going to familiar with it and remember. Last example we are going to see here is this example of shock. So during shock, it's a well-known fact that blood pressure decreases. This decrease in blood pressure leads to decrease in blood flow to the heart. This leads to weakening of cardiac musculature. This weakening of the cardiac musculature leads to further decrease in blood pressure. Why? Because the cardiac musculature are being weak and they are not able to pump enough blood. Why? In the first place, there is decreased blood flow to the heart. Why? There is already decreased blood pressure due to the phenomenon of shock. This phenomenon of shock is to further decrease in blood pressure. This is a very critical moment. We cannot let this happen. This leads to shock worsening further. So this is an unwanted situation we need to avoid. For this reason, we say positive feedback is not always beneficial. As you have seen in this example of shock, that leads to further increase in the blood pressure, further decrease in blood pressure, and we don't need this. Could be fatal if not treated. It could be fatal if not treated. So this positive feedback is not always beneficial. So this is called vicious cycle. We sometimes get this reasoning question. Positive feedback is sometimes also called vicious cycle, or positive feedback is not always beneficial. So we need to give this example of shock that leads to further decrease in blood pressure that could be fatal sometimes. So we have seen in this positive feedback regulation 5 examples, that is the clotting mechanism. So C, there is an LH surge, this is an L. Then there is an action potential, this is an A. Then this phenomenon of parturition, this is P. The final, this phenomenon of shock, which leads to the vicious cycle of positive feedback, this is S. So we can remember the examples of positive feedback mechanism as CLAPS, claps, where C is for the clotting cascade pathway, L is for the LH surge, A is for the action potential or the Hodgkin cycle, P is the parturition phenomenon, and S is shock. You are going to remember this mnemonics, claps, for positive feedback regulation examples. Next we are going to discuss is the anticipatory mechanism, that is the feed forward control system. We are going to understand this by some examples, but first we need to understand something, that there is no stimulus. This we have to remember. We have seen in the positive and feedback mechanism that there is a stimulus that leads to activation of some receptors that send signals to the central nervous system or peripheral nervous system or to the spinal cord. But in the feed forward control, there is no stimulus. This is the first understanding we have to get, which means we are simply thinking of the action. We are only simply thinking of the action. We only think of the action. For example, this action could be an everlasting example of exercise. We only simply think of exercise. Then there is no need to happens of exercise. There is no stimulus of exercise. This leads to increase in heart rate, increase in respiratory rate. This increase in heart rate is called tachycardia. And as we are anticipating, this is called anticipatory tachycardia. Similarly, this increase in respiratory rate, anticipatory tachypnea. So you've seen this classical example of exercise, how merely simple thinking of exercise can lead to increase in heart rate and increase in respiratory rate. This increase in heart rate is called anticipatory tachycardia. Increase in respiratory rate is called anticipatory tachypnea. So next example we are going to see in this feed forward. This is the first example. The next example we are going to see is the regulation of body temperature. So we have two concepts here. We have a skin temperature, with the outer surface of our skin. This temperature is called shell temperature. The outer shell of the body, that is the skin. The skin temperature is called the shell temperature. Another we have the internal organ temperature. This is called the, as it is inside our body, this is called core temperature. Skin temperature is called the shell temperature and the internal organ temperature is called the core temperature. When we are exposed to cold outside, our shell temperature, is our temperature of the skin, drops, falls. And in fact, we need to remember that our body temperature is regulated at the level of hypothalamus. So our hypothalamus anticipates. It is an anticipatory mechanism. So anticipates my core temperature is about to fall. As we are exposed to the cold, our shell temperature drops. Our temperature, which is controlled at the level of hypothalamus, anticipates that my core temperature is about to fall. It has not fallen, it is about to fall. It anticipated that it is about to fall. So this hypothalamus produces responses. Example, shivering. We tend to shiver during cold temperature in cold environments as a mechanism of increasing our body temperature. It produces responses such as shivering to maintain our core temperature. So I've seen this regulation of body temperature in this example of anticipatory mechanism. When we're exposed to cold, our shell temperature, that is the skin or outer temperature, drops. This hypothalamus anticipates that my core temperature is about to fall. Is about to fall. Is about to fall. So it produces responses. For example, shivering to maintain our core temperature. This temperature control by hypothalamus is an example of an anticipatory or feed-forward mechanism of regulation. A third example we're going to see in this feed-forward is a role of cerebellum. Cerebellum is concerned with motor control. We are going to see how it is concerned with motor control in central nervous system videos. For now, remember that cerebellum is concerned with motor control. In some of the places, it anticipates and thinks about our future. Here also cerebellum anticipates. For example, we are driving on a road. Suddenly a car or a bike or a vehicle comes in front of us. So we might have just 1 or 2 seconds to apply the brakes suddenly so that we don't get crashed with it. But a cerebellum which is concerned with the motor control, as we have seen, it anticipates. It already anticipates what's going to happen in the future and fires the motor systems so that we apply our brakes and prevent the collision. So this is how cerebellum, concerned with motor control, anticipates and thinks about future. So we have seen 3 examples here in anticipatory or feed-forward control system. First, we need to understand there is no stimulus. Seen 3 examples. By merely thinking of exercise, there is anticipatory tachycardia and anticipatory tachypnea. Then there is regulation of body temperature by hypothalamus. How, when exposed to outer temperature, hypothalamus anticipates and either decreases or increases our core temperature by producing some responses. And the third example is the role of cerebellum, is concerned with the motor control, how it anticipates and thinks about our future. So last concept we are going to learn is that homeostasis. In homeostasis, there is a constancy of body parameters. For example, we often denote the resting heart rate as an average value of 72 beats per minute. This is an average value we tend to denote. The average value. But in physiology, we tend to see the values of our body systems as range of values. For example, our heart rate at rest ranges from 60 to 100 beats per minute. So value you need to remember. Our heart rate at rest or resting heart rate ranges. Every physiological value in our body has a ranges from 60 to 100 body beats per minute, but we denote as average value as 72 beats per minute. So there is a fluctuating limits of parameters. There is always a fluctuating limits of parameters. Next we are going to see a concept of priority. Concept of priority during homeostasis. The body gives priorities to some parameters over others. Our body gives priorities to some parameters over others to maintain equilibrium. To maintain equilibrium, our body gives priorities to some parameters. For example, pH changes. If our pH changes even a bit, like 0.1 or 0.2, our major body systems would start to fail, would stop functioning. So the body gives priorities to some parameters such as pH changes. Another is the blood pressure changes. Blood pressure changes affects the blood flow to vital organs such as brain, the controlling system, liver, chief source of enzymes, heart. As you have seen in the vicious cycle, decrease in blood pressure leads to further decrease in the blood flow to the heart, to the kidneys, that maintains our pH as well as the osmolarity as well as the body fluid changes. So this blood pressure changes affects the blood flow to vital organs. So the body gives this priority to some parameters such as pH changes and blood pressure changes. So with this we conclude our homeostatic video. I hope you understand. It's a very simple topic. It's a reminder to do revision. Revision is an important, or I would say, key in remembering everything. Those who revise well do well. Thank you.